Welcome to the Stormsurf video surf forecast for the week starting Sunday, February 17th. Looking at significant wave heights for the North Pacific Ocean, we see an area of low pressure, gale, generating 30-foot seas, but all aimed up at the Aleutians and of no real interest. And then another cut-off low, generating barely 20-foot seas north of Hawaii, mostly aimed west of the islands, but a little bit of energy pushing into Oahu and Kauai. But overall, a kind of a weak pattern. You also see wind swell being produced off the California coast, and that really seems to be the theme of what's going on, at least for the moment. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they do form, help direct their path. As you can tell, we're still having difficulties with our weather models. We're trying, supposedly the software that we use to produce the models is in the process of being updated and can handle the secure connections that NOAA has now put in place. They're working on it, maybe another week or so. We're not sure. In the meantime, we're trying to find we're working on another backdoor method, but having very limited success. So we're going to use other people's sites for now. All right, so we're looking for a trough. That is a dip in the jet, sort of like what's here. And that, of course, helps support, you can see it there, upper level low pressure and surface level low pressure, counterclockwise circulation. Of course, low pressure generates wind, wind generates seas. Seas, as they radiate away from the fetch area, turn into swell, and that creates surf when it hits your coast. So for right now, yeah, there's a bit of a trough. It's a weak trough. Winds, in the 110, 120 knot range, a couple pockets, maybe to 135 or so. Not particularly strong. And then the jet splits west of the dateline. Massive ridge here, as has been the case for several weeks now, from the dateline almost to the U.S. West Coast. Then the jet consolidates, pushes onshore over Southern California, then really takes off from there. But that's not of interest to us. So when you get the split pattern, as you can see right here down the surface, you typically get high pressure, and that doesn't do anything but generate north winds in the case of California and easterly winds in the case of Hawaii in this position. So the only place really favorable for supporting low pressure development is way over here in the West Pacific, and that's not doing a whole lot. We'll put this into motion. You can just kind of see more of the same pattern. Yeah, a little bit more of a trough digs out as we get into Tuesday, but nothing substantial. Wind energy, the split even retrogrades further. The jet pushing down the coast and into Wednesday and Thursday. I mean, it just looks like wind, and then the jet really falls apart. Still split. A little bit of energy building as we get into Thursday, pushing off Japan. Winds about 140 knots, but just nothing too interesting. And then as we get into maybe Saturday, things improve a little bit. Still, massive ridge, big trough here, mainly inland. Good for weather maybe in the Pacific Northwest, but just kind of not looking very good for swell production. Then finally, there's some hints that this trough might blow up as we get into Monday, February 25th, and we're out about a week out. Notice wind energy building in the jet. Wonder why that is? The active phase of the MJO is right down here, just raging. So one would expect that the jet stream would start waking up at some point. Kind of surprised it took this long. And as you notice, look at this as we get into, we're just going to go out. This model goes a little bit further into Tuesday. Jet builds. Looks like the split is starting to dissipate a little bit, trying to make some progress. And we're just going out and out. Maybe not. It's hard to say. We're out 2 weeks now. Still no significant improvement. All right, let's go take a look at surface level pressure, and these are 850 millibar winds, so they're a bit stronger than what's at the surface. But anyway, you see low pressure. This is what's generate the seas up there by the North Dateline region right now, and that system quickly fades out. Here's our surface high pressure, 1043 millibar high, completely bulletproof, well dug in, and you see the picture here. Just there's really no significant low pressure development at all. Here's the system, but again, south winds as we get this is into Thursday, just pushing into the Bering Sea. Another one, 50 knot winds pushing up straight up into the Aleutians. This high pressure here just locking things down completely. And where are we at? We're at almost a week out now. and no obvious signs of swell production as we get into a week out. Also notice low pressure down here. With the MJO raging, that's probably a bit of a reach to have a tropical low this time of year there, but still interesting. It's all attributable to the MJO. All right, so let's take a look at the effect of those winds on the ocean surface. As we said before, tiny little gale. We know where this is going, up into the Bering Sea, 30-foot seas, not doing anything, and then our cutoff low here north of Hawaii. Roll this out. You can see just not a whole lot happening. We're looking for anything. Here's that tropical low produced by the MJO. We're looking for 22-foot seas aimed at either Hawaii or the U.S. West Coast. Still not seeing it. Little low dropping down the coast as we get into Friday. That's good for probably weather and more wind swell along the U.S. West Coast. Look at the size of that tropical system. Do you believe that? I wouldn't, but it's kind of interesting nonetheless. And here we are. We're almost a week out and literally nothing on the charts. What is that? 15-foot seas, 16-foot seas. Just no real swell production at all. Very perplexing. All right, let's take a look at winds. So we can't get Hawaii on this chart, but we can get the U.S. West Coast. You can see the north wind situation right now. The greens are 20, 25 miles per hour. That continues less so into Monday, maybe even a light flow near shore. And then into Tuesday, things fade off a little bit. Still, you can see the next batch of north winds coming. Here it comes. I mean, this is almost like a springtime pattern. Total springtime north winds nuking, but it's in middle of February, and it's been going on for, 2 weeks now? So there you go. We're into Wednesday, Thursday. Again, 25, 30 knot north winds. It just doesn't give up. We're into Friday, and then finally things settle down maybe Friday for a little bit. Let's see what happens Saturday. Here comes another low moving into the same area, and winds lightening up some. Lighter. What's that? That's 15 knots, but still out of the north and not giving up anything. And then let's check out precipitation. Greens are liquid precipitation. Blues are snow. We'll just see how this goes. A little bit of snow up in Tahoe, fading out as we get into Monday. Clear skies, and then precipitation working its way down the coast into the Pacific Northwest, but not doing a little bit of snow, a little bit of rain, scattered rain along the coast Wednesday night into Thursday. That fades out, and then we have another shot maybe in Northern California as we get into Saturday and Sunday, and then we're at the end 180 hours out. So no significant precipitation forecast. All right, so let's go take a look long-term. What's going on with the MJO? Though we've already let the cat out of the bag there. And what's going on with maybe El Nino? I guess we're going to find out. As usual, we'll start this portion of the tour looking at winds across the equator. This is the East Pacific here. This is the West Pacific here. These are winds from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. You can see the arrows is what we're looking at. The colors are water temperatures in Celsius. We're ignoring that. East winds in control. These are 5-day average winds until you get to the date line. And then look at this. West winds developing. This is the Kelvin wave generation area, we call it, when you get west winds in this area from about 135 east to 170 west, and they blow for a decent length of time. That takes warm water that's in this area. It starts pushing it east, but not on the surface, at depth, and makes it the whole way across the Pacific, then erupts off of Ecuador to the ocean surface, creating a warm slick. If you get enough, it takes about 3 months to make that journey. If you get enough of these Kelvin waves, and they're all driven by the active phase of the MJO, then you can possibly get El Nino. It's anomalies that we're really interested in. Are these winds stronger or weaker than normal for this time of year? And you just look at the arrows, you say, a little bit stronger from the east over here in the East Pacific. But in the West Pacific, very strong from the west. This is being driven by the active phase of the MJO. When you get strong, prolonged westerly winds, that's called a westerly wind burst. That's an exceptional sort of strong active phase of the MJO, and that's exactly what it looks like is happening right now. So that's good news long term for the future. So what's been happening the past couple of days? So this is 850 millibar wind anomalies. That's up about 4,700 feet, something like that. And the equator's actually right there. Okay, so there's South America, Central America, Philippines, New Guinea. Kelvin wave generation area. There's your equator right there. Kelvin wave generation area. From here, about 5 degrees north and south of the equator, draw a box in your mind right about there. So there's westerly anomalies, but for the most part, they're south of the Kelvin wave generation area. That was on February 11th. You can just sort of look down here, maybe lifting a little bit north. A lot of westerly winds in the southern Kelvin wave generation area through February 15th. Let's go look at the forecast. And here we go. Okay, so this chart is the whole planet on one chart. Okay, the date line runs right up the middle. We have dates here on the side so you can see past history. Reds and oranges are westerly anomalies, and we want them in the Kelvin wave generation area, so basically between these two tick marks. Okay, so you look here, and not only does this help create Kelvin waves, it also imparts energy to the jet stream normally and helps fuel storm development. So you see the whole later part of January, westerly winds were in the Kelvin wave generation area. They backed off for a little bit. Now they've been extremely strong from February 12th through today, just about filling the Kelvin wave generation area, and are forecast to continue, though weaker, for the next week. So definitely, this is a westerly wind burst. This is the strongest bit of westerly winds we've seen for quite a while, and likely possible to generate another Kelvin wave. So let's go out 2 weeks. This is outgoing long wave radiation model forecast. Another way of monitoring the MJO. Okay. The blues are less sunlight reflectivity off the ocean surface, negative anomalies. That means clouds. That means low pressure. That means the active phase of the MJO. Reds, more sunlight reflectivity, high pressure, or the inactive phase of the MJO. So for this model, the statistic model, the active phase of the MJO is on the date line and forecast over the next 2 weeks to wither and die out as the inactive phase moves in. But the GEFS model, showing a little bit more cohesiveness of the active phase of the MJO, but it too moving out of the Kelvin wave generation area. But you can see here, inactive phase per the statistic model is supposed to be in the West Pacific 2 weeks out. Maybe not quite as strong, but pretty much over about the next week to week and a half, I'd say the active phase of the MJO is to die per this model. The long-range upper model, this is areas favorable for precipitation. The greens are favorable precipitation. The reds not. The greens generally could be construed to be the active phase, the MJO. This is the inactive phase. So the active phase, let's say, is in the Central Pacific and expected to move into Central America through about the 9th of March. Inactive phase developing by the 22nd of February. And this model runs maybe 5 days ahead of, this is upper level, 5 days ahead in the upper levels of compared to what's going on at the surface. And it traverses the Pacific and into Central America by March 24th, and then another active phase after that, let's say mid-March into the end of March and beyond. And yet another model. So this is goes out a month. This is, again, whole planet on one chart, Kelvin wave generation area between these two tick marks. You just go right up here, and you want to see red anomalies. Those are reds. Those are westerly anomalies, and you want to see a black line like that's the active phase of the MJO. So according to this model, we have strong westerly anomalies in the Kelvin wave generation area, and they're building and forecast to hold through, let's say March, so for the next 2 weeks to early March, and then fading, but not completely out. I mean, if you just look at this chart, the preponderance of westerly anomalies, they've been nonstop for 1, 2, 3 months and going on. This very much looks like some kind of El Nino, but we know for a fact that we're not in El Nino right now. I mean, or weak. I think NOAA actually declared it a minimal El Nino, even though there's not a tremendous atmospheric response to it. It's still seems to be helping to some degree, at least getting precipitation into California. No one can argue with that. In terms of surf, been pretty lackluster the past month or so, something like that. There's been waves, been a lot of wind though. All right, let's keep going. And then our favorite model, the CFS model, 850 millibar wind anomalies. Okay, so this one's a little different. This is past performance here. This is the future forecast here. Again, Kelvin wave generation area between these two tick marks. We're looking for westerly anomalies. We see right now, here is our major westerly wind burst. I mean, compared to anything that's gone on since October, for sure, the strongest westerly wind burst we've seen in a long time. And you can just eyeball right up here. Man, it just isn't forecast to stop for into May. If this was ever sort of the picture you want to see for a developing El Nino, this is it. We thought we're getting there this past year, 2018. 2019, things looking a lot stronger. Let's overlay the MJO. Here you go. This isn't even a strong active phase of the MJO. In fact, when you get El Nino, the MJO just starts disappearing. And what do we see? After we get into about March or so, the MJO just fades away. And it's normally the active phase of the MJO that drives westerly winds. But when you have no MJO and you have solid westerly winds, that definitely smells like an El Nino setup. So anyway, here's our active phase of the MJO. It's pretty much out of the Kelvin wave generation area by the end of February into early March. No surprise, inactive phase takes over the dotted contours, but notice westerly anomalies holding. Then a very weak active phase is suggested maybe in mid-March or so. Then the MJO dies, but westerly anomalies keep going. What's going on? Let's add the low-pass filter, and you're going to see it right here. Boom. All right, so here we were. Last year, we had this is the low pass filter. Basically, when you see solid contours, that means areas, biased towards low pressure. And all last year, we had this 3 contour thing going. We thought we were in El Nino, and then it just died in December. When it was supposed to be strongest, it died out completely. The MJO woke up and started pumping, and that's kind of where we are now. But now it's interesting. 3 contours have started redeveloping in early February, but this is even more interesting. A 4th contour is supposed to start developing in late March, and that's right about the time, we're talking March, and you wouldn't think you have El Nino till December, like, what's that, 7 or 8 months later? But this is typically when El Nino starts, is in the, February, March time frame, and then it builds the whole way through the spring, the summer, into the fall, raging in December. So we're supposed to have 4 contour lines. So theoretically, this, if it materializes, would be stronger than anything we had last year and maybe nudge us into a legitimate El Nino as we get into the summer and beyond. That would be a really good thing. Now, do you believe a model 3 months out? I don't, but at least things are going in the right direction. We're not in La Nina. Maybe we're moving towards El Nino. All right, enough of the MJO thing, and let's go take a look at what's going on in the oceans. There's multiple components to El Nino. One of them's this MJO thing. That sort of gets things cooking, right? Westerly wind bursts, low pressure biases, all that kind of stuff. But El Nino really manifests in terms of what's going on with temperatures in the ocean. So here's the East Pacific, here's the West Pacific. This is the data from the TAO buoy array right on the equator here. These are the anchor lines on the TAO buoys. These are the sensors. The X's are the sensors on the array. They get temperature data down into the ocean, down 200 meters, 300 meters, okay? And then you use a model to sort of connect all the dots and fill in the blank spaces. And what you get, warm water in the West Pacific, no big surprise, 29 degrees, and then cooler water in the East Pacific. Because why? Well, you always have trades blowing from east to west, and they take warm water, any warm water that's in the East Pacific, push it off to the West Pacific. So it's normally balled up over there. During La Nina, the trades are a lot stronger. They blow harder, and they take any warm water here, push it off to the west. During El Nino, you get those westerly wind bursts in the West Pacific right here, going from here to here. Take some of this warm water, starts pushing it off to the east, and you see the 28-degree isotherm line, it's holding steady at about 162 west. The 24-degree isotherm line right here, during La Nina, it would be back over in here, but it's pushing into Ecuador, meaning warm water is moving east. All right, let's take a look at anomalies, differences from normal for this time of year. And what do we see? Well, here's the date lines like right here? I'm sorry, there's the date line right there. We see warm water, 3 degrees above normal, moving from west to east. If you follow this every week, this was back here a couple of weeks ago, and that 3 degree, positive 3 degree warm bubble, it's moving east. And you also see a river of warm water, 1 degree above normal, working its way to the east. So this is a Kelvin wave pushing east. This would be Kelvin wave number 3. Not particularly strong, but a Kelvin wave nonetheless. And with all the westerly anomalies blowing over here, maybe there's another Kelvin wave being generated. All right, and here's another model. Same raw data, just a different view of what's going on. We see cold, that blue, cold water here in the East Pacific. That's the upwelling phase of the Kelvin wave cycle. So typically when you get a Kelvin wave pushing in, and there was a Kelvin wave that moved into Ecuador, a month ago or so, and then you get a pocket of cool water, and then here's Kelvin wave number 3. It looks a little bit more substantial on this model with 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Pockets of 4 degree anomalies, but mainly 3 degree anomalies. Here's the date line here. Also notice this wasn't here before. Remember, we had westerly winds just developing the past 5 days. It already looks like warm water is starting to trickle from the maritime continent into the West Pacific, maybe creating yet another Kelvin wave. So this is all good news. All right, sea level anomalies, just another way to confirm whether there's warm water at depth. So there's South America, there's Mexico, New Guinea there's the equator, there's the date line. You see this bubble of 0 to 5 centimeter positive anomalies right here. Okay, so this is from the JSON-2 satellite, or JSON-3. Basically, you take the data, you strip out all the wave heights, strip out the wind waves, strip out the tides. What you see is the ocean has a bulge on it, a 5 centimeter bulge. That's not very much. It's a couple inches, right? Okay, but the point being that warm water expands at depth, and if you have a bulge right here on the equator, and that's all we care about is the equator, that means that there probably is warm water, a Kelvin wave, a fairly substantial one, extending from 160 east to about 120 west and moving to the east. There's your pocket of cool anomalies, a negative anomaly, a depression in the ocean surface, and that's the upwelling phase of the Kelvin wave cycle. So this just confirms what we saw in the other charts. All right, and upper ocean heat anomalies. So this is sort of a historical chart. Last year, so this is the West Pacific here. This is the East Pacific here. We're basically on the equator. You see the blues? That's cooler anomalies. There you can see it. This is last year, March, about this time last year. Cool water is the last of La Nina. Cool water in the East Pacific, warm water in the West Pacific. You can see warm water started moving from west to east. Just sort of eyeball it right along that line. That's Kelvin wave number 1 that impacted Ecuador in the July timeframe. Then much stronger Kelvin wave number 2. September, takes about 3 months to get across the Pacific, impacting Ecuador into December or so. And then here's where we are right now. This is the upwelling phase of the Kelvin wave cycle. There's our cool pocket. Just like here, we'll go this way. There's Kelvin wave 1. There's the upwelling phase of the Kelvin wave cycle there. Kelvin wave number 2, upwelling phase of the Kelvin wave cycle. Here's Kelvin wave number 3, developing right now, and maybe Kelvin wave number 4 is going to get started if this westerly anomaly thing keeps happening. All right, so what's going on temperature-wise at the ocean surface? We've talked about the MJO, we've talked about westerly wind bursts pushing warm water in the form of Kelvin waves to the east. We've looked at our subsurface temperatures, but the surface is kind of where it has to come together, because it's the warm water on the ocean surface in the East Pacific. This causes evaporation. Evaporation then starts imparting energy to the atmosphere, and that in turn starts driving the jet stream, and that's how you get El Nino. Okay, so right now, yes, we have warm water. So actually, what's El Nino look like when it's raging? You got a lot of warm water. Here's Peru. It would be all along here, up here like it is, and then out to the date line, sort of like in a triangle fashion. You can kind of see roughly that pattern, but it's very weak. I mean, yeah, there's some warm water along Peru, but there's this finger of cold water. What's that doing there? That's the last thing you'd want to see if you had a real El Nino going. And yeah, you have warmish water up here off of Mexico and out to the dateline. And now the thing that is kind of interesting, there's been this persistent pocket of cooler than normal water over here, the last remnants of La Nina. That finally died, I'd say, this week, and we're in a fairly neutral regime as of right now. So yeah, we do have warm water, but you got this kind of mixed bag thing. Just doesn't look very good, particularly interesting. Here we go. There's New Guinea. It goes out to, yeah, the dateline, and then nothing particularly interesting. The trend for the past 7 days, you can see generic warming the past 7 days out here. It's on the equator. It's in this area that if you're going to have El Nino, normally your warming is over here. So clearly there's warming here off of Central America and Peru. It's still cool. This cold burst like a easterly wind burst over the Galapagos, causing upwelling there. You know, no clear sign of anything going one way or the other. It's not neutral. It's definitely biased warm, but not amazingly so. And then the overview picture. Again, if you had real El Nino, you'd want to see this big red triangle right here. We're not seeing it at all. We're seeing generic warming, but if you look at the whole planet, there's a lot of warming everywhere. I mean, this is, the oceans have been steadily warming, and every 5 to 10 years NOAA has to reset its data. So how, you know, you get data year after year after year, you sort of average it all out and go, okay, where is, you know, what's the average temperature for this time of year in this part of the ocean? That's how they build this. This is an anomaly chart. These are differences from normal for this time of year, but it's basically saying the whole ocean's warmer than normal, and that's because it is. And there's no denying that fact. Okay, but when you're looking for El Nino, what you want to see is a marked warming in this area here. Yeah, we're seeing some warming, but nothing significant. I mean, especially when you consider what's going on elsewhere in the planet, it's just kind of neutral, a little bit warm, no big deal. So here's the temperature trend in the Nino 1.2 region. That's the area, in fact, we'll go up here and just show you. Nino 1.2 is basically this area right along in here, okay? Not officially El Nino. The official El Nino monitoring region is out here. But this is sort of like the birthing ground where Kelvin waves erupt, and it sort of gives you an early warning of what's going on in you know, the ocean. And the trend here, you can just draw a line through this and go, certainly looks like it's down. Today, we're 0.173 of a degree above normal, you know. But the trend, looking downward, not looking particularly impressive. In the official El Nino monitoring region, we're 0.3 of a degree, right there, 0.316 above normal. Okay, to have El Nino, you got to be half a degree above normal for 5 months running. And we're, if anything, if I were to put a trend line through that, I'd say it's going down as well too. Now the real question is, are there more Kelvin waves coming? Because that would nudge it up. And to do that, you need westerly wind bursts. And to do that, you need the MJO. So you see how all this stuff kind of ties together. Right now, doesn't look like El Nino, but if one believes the models, this whole should turn around in about the next 3 or 4 months. All right, so then we've talked about the westerly wind bursts, the MJO, warm water, subsurface in the ocean moving from west to east. We've talked about the surface temperatures off of Ecuador and all that, but all that has to drive changes in the atmospheric circulation, okay? And what it has to do is it has to basically affect the jet stream. One way of measuring the development of El Nino is this thing called the Southern Oscillation Index, SOI. Difference in pressure between Tahiti and Darwin. When the pressure on average drops over Tahiti and builds over Darwin, that's a sign of El Nino. When you get that, this index, the daily index, or the index goes negative. Now, interesting, look at this. Remember we said there's a strong westerly wind burst, strong active phase of the MJO? Well, look at these numbers. For the first time in a very long time, they're going very negative, minus 23, minus 25. You know, you get it. Today, minus 29.88. That's the strongest. Let's go back the past month. It's just been positive. This is the deepest negative it's been in a long time, so that's a good sign. And it is taking the 30, you take these numbers, average them out over 30 days. That takes some of the noise out of it. When you see the index dropping on the 30-day average, that suggests the active phase of the MJO, a strong one. And you really want to see this go down to like minus 15 or something. We're at minus 4.72. Then the 90-day average takes even the MJO noise out of it and helps you decide, do you have El Nino or La Nina? This guy needs to be negative, like minus 10 or 15, before you can declare El Nino. Right now it's positive 1.12, and you sort of look back here and the numbers have been hovering in the positive range. So we're nowhere near El Nino per this index, but at least we're neutral. We're not in La Nina. If it was positive 10 or something, then we'd be in La Nina. We're nowhere near that. And then one final index. This one, the ESPI index, ENSO precipitation index. Rather than measuring difference in pressure between the area north of Darwin and Tahiti, you measure the difference in total rainfall amounts. And, you can do this with satellites and see, do you have more rainfall here in normal? Because remember, if you have warmer than water, that's South America there. There's Australia. This is the equator. There's the dateline. If you have more warmer than normal water here, then you get more evaporation. If you get more evaporation, you get more precipitation. That imparts energy to the jet stream. That changes the jet stream configuration over the Pacific, and that is the hallmark of El Nino, and that starts driving the jet into California, making precip. But the key here is it has to be a consolidated jet stream pushing across the Pacific. So the rainfall that we're getting right now into California is not El Nino related in any way because the jet stream is massively split here. It just happens to be split in a way that the split point isn't over California. It's out in the middle of the Pacific, so it's driving precipitation down into the U.S. coast, and California and the Sierra is the beneficiary of that. We'll take it any way we can get it. Anyway, okay, ESPI index is, if it's negative, that means there's less precipitation here. If it's positive, that means more precipitation. It's weekly positive, 0.22. That's good because it's been just hanging around 0 or even lightly negative for pretty much the whole year. It's now, I think we had it up to 0.29 for a week or two, a couple of months ago, when we thought El Nino was developing. Then it crashed. Now it's starting to work its way back up. We'll see where we go, but effectively, it's neutral. And then finally, the sea surface temperature forecast for the Nino 3.4 region. This is the official El Nino monitoring region in the ocean, sea surface temperature. Now, this is kind of laughable, right? Okay, so we were talking for El Nino in this region, you have to have half a degree or longer for 5 months. And you can see right here, the solid line is not a forecast. It's what's actually happened. Yeah, we've had above normal temperatures for, what was that, September to end of October, November, January, early February. So what is that? 3.5, 4, almost 5 months. So yeah, minimal El Nino from a sea surface temperature standpoint. From a jet stream perspective, I'll say no go on that. From a storm perspective, it was doing pretty good up till about 3 or 4 weeks ago, and the jet split then, and everything's fallen apart. And that's pretty much, remember the low pressure bias that we looked at. In fact, we'll go back here. Remember this chart? This low pressure bias over the dateline where it went from 3 contours to 2 contours, and what was El Nino kind of fell apart. Well, that is, we think, kind of what caused this to fall apart as well. Sea surface temperatures never got where they were supposed to go. The low pressure bias, westerly wind burst, was supposed to be driving temperatures up. We were supposed to have like 1.2 degrees above normal right now. Instead, where are we at? And this says 0.6, but the data we just saw said we're really down somewhere around here. Anyway, so the forecast, this is highly optimistic. We're not buying into any of this. It says somehow temperatures are supposed to magically skyrocket up into the 1.25 degree above normal range by April. Say, low chance of that. We'd be lucky to get to 3/4 of a degree above normal. Anyway, but the good news here is the forecast says that we're supposed to stay warm as we get into the fall of this coming year. And that's good. I mean, all that does is help support the jet stream. You know, warm temperatures feed the jet stream feeds the storm track creates surf and rain. And so it's way better than being down on this portion of the curve. Of course, and we've been saying also that we almost kind of hope this doesn't materialize, that we just have this slow warming thing that goes on, because that really tends to put the atmosphere in motion and put some momentum behind it. Not El Nino, because if you get El Nino, then you know the next year you're deep into La Nina and things just fall apart. But a slow, steady warm might be the answer and would be good to see for a couple of years. And it happens. It does it. You don't really get El Nino. And then if you have that slow, steady warm, you don't get the crash into a deep La Nina either. So the forecast, cautiously optimistic. All right. So for now, well, the jet stream is kind of just hosed. It's split. The MJO theoretically should be healing it, but looking at the models, we're not seeing it. We're seeing hints of maybe that giant split disappearing, but for now, I think it's here. It's almost like spring is setting up, which is hard to believe. North winds in control, cold water, just nonstop chop for California. Funky conditions for Hawaii as well. Very strange setup. Longer term, though, we think things are doing better. I mean, the ocean's warming. We're not in La Nina. This summer, as we get into the summer time frame, we should get a pretty decent summer out of this. We'll go crunch the numbers and figure out exactly where that forecast should be for the summer, but at least average is our expectation, maybe a little bit above average, sort of like the winter, like a 6 on a 10 scale, something like that. And then possibly some form of warm El Nino-ish like pattern setting up through the summer into the fall. Who knows? Long ways away, but certainly, again, not La Nina. That's a pretty good place to be. All right, so that's it for this week. Next week, we're going to be on a little bit of an off schedule. We'll do the forecast, but we'll probably do it like on a Friday, something like that. And then the week after that, we'll be back on track and should be for the foreseeable future. So that's it for this week. We'll do it again next week, probably on Friday. Until then, thanks for watching. Take care.